We are now joined by Christian. Christian currently works on the customer and field engagement team in the hybrid platforms business unit within Red Hat. He's a technologist with experience in infrastructure engineering, systems administration, enterprise architecture, tech support, and management. Christian is passionate about open source and containerizing the world one application at a time. Lately, he's been focusing on Kubernetes, microservices, cloud-native architecture, and GitOps practices. Christian, what do you have in store for us today?
Hi, my name is Christian Hernandez. I am a senior principal technical marketing manager at Red Hat. I work on the GitOps team, OpenShift GitOps team, which uses Argo CD as its continuous deployment tool set for OpenShift. And today, I'm going to be talking about Argo CD and Stateful Applications. Stateful Applications is something that is always a challenge. And I'm here to share some of the tips and tricks that I've learned along the way of working with Stateful Applications and Argo CD. Anytime I do a talk, I always like to start off with a good quote. And so I found a great quote from Christian Posta, who is currently the field CTO at Solo.io, former Red Hatter. And he did a presentation at Red Hat Summit in 2017 about microservices. And he explained that the hardest part of microservices is your data. And although this talk talked about the sharing data between microservices, it did touch on an interesting subject about how that it's a challenge in cloud native computing and with, in your DevOps methodologies and your DevOps practice that is always there. And it's always a challenge of specifically nowadays to cloud native computing. And that is your data. And when I say your data, I'm talking about stateful applications. And so I like to borrow / amend Christian Posta's quote, and by saying that the hardest part of GitOps is your stateful applications. One of the many benefits of GitOps is that it reduces the time to recovery, right? That's one of the things that that you get by doing GitOps practices. And the idea is you just reapply the manifests and you're back in business, right? You have an outage, you spin up a cluster, you reapply your manifests, and you're back up, right? That's kind of the whole idea. And as we all know, and hopefully none of you have been into any serious problems, but it's a little bit more complex than that, right? And you always think about, what about your stateful applications? What was the data lost? Were you hosting a database? Do we need to recover data from a backup? What was the application storage pointing to exactly, right? Where was it? What was it consuming storage? So depending on what happened, you may need to take a different approach on restoring those. So just a point of reference, in this talk, I'm going to be focusing on recovering from an outage specifically, right? So failing over to another site and general disaster recovery is kind of out of scope for this talk, but I just won't have time, right? It's a big topic, but hopefully this can kind of give you ideas in preparing for those kind of scenarios. So the challenge of stateful application isn't something new, as I said before, but it is, a general problem, and hopefully you can start formulating some disaster recovery processes around what you learned today. So first, I like to talk about storage with Kubernetes from a high level, just from a generic standpoint. Storage has always been a challenge in Kubernetes. It's from day one, right? So ideally, all of our applications will be stateless, but that's honestly not the world we live in. In the world of IT, whether you're doing cloud native, state/data is always at the center of everything. It's no different with Kubernetes, right? So, traditional application development and application development on Kubernetes, there's a lot of differences, but really what they have in common is the data, because that's really the center of the world. Even with cloud native applications, you need to store state somewhere. So this is where the persistent volume claim paradigm came to play. PV and PVC, right? Persistent volume claim, allowed a way to abstract the storage and it abstracted the storage from the application to where the idea was that the application just says, hey, I need some storage, and everything else kind of automatically happens on the back end. And so some of the things that came along with that is storage classes, right? So like after that came about, storage classes were there to help to tier the storage. So that way you have, I need ultra fast storage. I need, I don't care as long as the data is available. Gold, platinum, that kind of idea with storage classes, right? That was all very manual, but then the advent of the idea of dynamic volume provisioning came to place, right? Where no longer administrators need to specifically create persistent volumes. There is a controller that created those volumes for you, right? So it connected to the backend storage, and it created those storage on the fly. So you never it removed the need for administrators to create those persistent volumes at scale, right? And now with CSI, this is making things easier, right? The container storage interface. So now you have a bunch of choices when choosing for storage, right? So now, before it was traditionally you just had block and NFS with Kubernetes. Now you have all kinds of choices that are provided for you. So GitOps and storage, right? Dynamic storage provisioning introduced a very interesting problem, right? So it was a savior, but then it introduced a problem with GitOps, right? So with GitOps, the representation of your application is stored in Git. So this allows you to quickly restore, an event of a failure, like I mentioned before. So is it, all unicorns and rainbows there? Well, not really. So if you think about it, the default reclaim policy for dynamic storage is delete, meaning that when the persistent volume claim is deleted, the backend storage is also deleted, right? So this, forget losing a cluster. Someone accidentally deletes a PVC, the storage behind it automatically goes away, right? And so even when setting a persistent volume claim to be retained, the backend, the restore can just still also be very manual for restoring. So and also most of the storage management still lives outside of Kubernetes. So there are some providers that have full integration with Kubernetes, right? For like snapshotting, resizing, but that's still something new, and that's still something that not a lot of administrators still do, right? So a lot, if not most, if not all, the storage management still happens outside of Kubernetes, right? So there's kind of like a disjointed thought behind, restoring your application. So there's other things to consider too when you're restoring from a catastrophe, right? You need to do things like file permissions, right? You need to make sure those are set. You need to think about whether you're going to restore from backup, or if you're running a database, for example. A lot of the restore and a lot of data management is built into a lot of database systems, right? So for example, Postgres, a lot of administrators can elect to just attach the storage and have the database try to repair itself. And then, you may or may not need to restore certain tables from backup. So that's kind of another decision you need to make. And so, that's kind of some other things to consider of, where does the storage live? And how is that management done, and what, how you're going to do that. So with that, I kind of like to bring up some of the tips and tricks that I've used. So don't use dynamic storage. So yeah, sorry, right? I know it's kind of no fun, but in the GitOps world, this is, I think this is actually an anti-pattern using, my opinion, using dynamic storage, right? So you actually want to specify the storage you are using for a specific application. If GitOps, in a GitOps world, you're using something as a source of truth, using dynamic storage, that can change on the back end, right? So no, you really want to have a one-to-one relationship from your storage to your application. Use label selectors, right, with persistent volume and persistent volume claim, right? So when you create a persistent volume, And persistent volume claim, you got to make sure they match up by using some things like labels. And then always remember, please set the reclaim policy to retain, so that way you lose any data in case of a catastrophe. And I like to set up security context constraints. Right, we're really big here at Red Hat with SEC, and I know a lot of that's been pushed up into Kubernetes proper. And so you can set up the security context constraints for the UID and the group ID for the application, right? And so this will help with like permissioning. And so with that, I had to go over a quick demo, really, really quick, because I know this is a short talk. So here I have an application. This application is a front-end web, three-tiered application, front-end web, back-end, and a DB, having a simple CRUD application, right? So I do have some data that is stored on the application here. If I look at the configuration for this, calling this out really quick, is the persistent volume here. And a few things I want to call out is that, one, I'm labeling this. Remember, label selectors is very important. I am setting the persistent volume claim policy to retain, and I'm setting the claim reference to say specifically satisfy this specific claim. So kind of mapping those one-to-one there. I have a volume I created on AWS specifically, right? So as you see here, I have a little cheat sheet here that I use. This creates the volume, and I use this volume ID specifically. I want to use this specific volume. And here, since EBS volumes are zone specific, I want to say make sure to always make it available in this zone. And the claim is very simple. It's kind of what you expect. A few things I want to call out is, one, I use the same label. I'm not using a storage class, so I leave that blank. And then I am doing a selector, right? And so this is how I keep them one-to-one. Looking at the database, because that's where my state is being saved, I am also doing a node affinity, right? So basically keep this a database in that same zone that I am that I'm deploying the storage on. So that way, it'll grab the right storage, and then using that persistent volume claim. I also want to call out that I'm using security context constraint, right? I'm adding a supplemental group, so that way the permissions always stay. This application runs always as this specific group ID, so that way the permissions don't get messed up. So if I go down here, and if I do a get persistent volume, you'll see that I have that persistent volume, and it's bound to that claim. And then that is bound there. So I have this application. So let's simulate an error by doing get the namespace. Let's see here, the namespace is here. So if I do price list is now in the process of being deleted. So as you see here, Argo CD automatically says, hey, this is out of sync. Things are being deleted. So the application is actually gone. So if I go over here and I reload this here, applications is gone. The PV is still there. So if I do a get persistent volume, it's still there. The status is now released. But in an actual failure, let's delete the PV. The PV will be gone, right? It's an actual failure. The persistent volume will be gone. And so this is kind of like, hey, either the project got deleted, the persistent volume got deleted, or the cluster got deleted, and we're just kind of simulating me reinstalling a cluster, right? So this is completely gone. The application's done. So all I have to do, right, is kind of just sync this back up. And so the idea being is that since I specified the storage specifically in get, as you see it in the YAML, and that was already created on AWS, and that volume was already there. Reapplying the manifests shows works, right? And so here, as you see, everything is starting to sync up. The very last thing to sync up here is the OpenShift route, which looks like I'm back in business. Everything's green. I have my data back, right? I can test this application, right? Argo CD t-shirt. And it's, let's give, $3,000 is give back to the community, right? This is fashion. And it looks like my application's up and running and it's working. So here, so I hope you enjoyed this presentation, and invite you to connect with me. I am available on the CNCF Slack and the Argo CD channels to talk more about stateful applications. Thank you.